This is the new Bluetti Apex 300, and it offers a lot of new features never seen before on a Bluetti power station. For example, this is the first Bluetti power station to offer 240 volt split phase output on a single unit. It's as simple as selecting the 240 volt option, and then you get 240 volts output. The Apex 300 is also the first device to support the new D1 hub, which allows for up to 50 amps of 12 volt output, or about 700 watts. And I'll show you guys later in the video that this is super efficient. Now you can also go big with solar charging on the Apex 300 with Bluetti's new external solar charge controller. This is the SolarX 4K, and it allows up to 500 volts of solar input, and it'll charge the Apex 300 at up to 4,200 watts. Now I will be doing a demo of this unit later in the video, and it's fairly plug and play. You take the end cable and plug it into the expansion battery port on the Apex 300, and then you connect up your solar input here, and it will start charging. Now another change that I like a lot are these new 90-degree adapter cables for the expansion batteries. Now you guys are familiar with the previous cables that are just really long, they take up a ton of space. Well, these just plug right in and they are super compact. Now those are just some of the new exciting features of the Apex 300, but let's take a second to go through the actual specifications, starting with the internal battery. First off, yes, this does have an internal battery, so unlike the AC300 and AC500 from Bluetti in the past, this has a battery inside the unit. It's rated at 2,764 watt hours. It's a lithium iron phosphate battery. It's basically the same thing that's inside the new B300K. Now the inverter on the Apex 300 is super unique. You get a combined output of 3,840 watts, and that's actually from two separate inverters. You can draw a line down the middle of the power station. Right here you have one inverter rated for 1,920 watts, and then on the other side you have another inverter rated for 1,920 watts. So combined together you get 3,840 watts output. Now the selector switch here at the top changes how they're wired together. For example, when you have it set to 240 volts, these are separated, so you get one inverter on one phase and you get another inverter on another phase for 240 volts split phase output. And then if you have it set to 120 volts, it combines both of these inverters together for the same amount of power output. It's just at 120 volts. Now because of the two inverters, it also has a 0 millisecond rated UPS. This side is rated for 0 milliseconds and this side is rated for 20 milliseconds, and we'll be testing that later in the video. Now looking at the right hand side of the power station, you do have two built-in charge controllers on the Apex 300. There are two XT60s. These are good for 12 all the way up to 60 volts with a 20 amp limit, and they're rated for 1,200 watts each, or combined 2,400 watts. Now these are designed for portable solar panels. You can use these in addition to the SolarX 4K, which connects into the battery expansion port here on the side. Now on the left hand side of the power station, you have a lot going on here. Right here at the top, you have your 120 volt input, and I have tested that this does allow 120 volt input and 240 volt output at the same time. So that's excellent on this power station. Right here, you have your 240 volt output. This is a 50 amp NEMA connection. Over here, you have an RV 30 amp output for your higher 120 volt output. And then right here, you have a proprietary connection that allows you to connect up to their hub. This allows for faster charging as well. They have a 30 amp input and a 50 amp input to charge with AC input here. So that's some of the basic features and accessories that are available for the Apex 300, and it really adds a lot of versatility. For example, you could use this in a portable setup to power your RV or a camper build with the DC1 hub, and you could use the built-in solar charge controllers for the portable panels or low voltage solar panels on the top of your trailer or RV. You could also use this power station as a home backup. You would take the selector switch here, turn it to 240 volts output, and you can plug this into a generator inlet or into a transfer switch and power your home during a power outage. You could add expansion batteries for longer runtime. You could add the SolarX 4K for high voltage solar. And of course, you can stack multiple units together to give you more wattage. So lots of versatility with the Apex 300. Now let's talk about price. Bluetti has opted to launch this power station via a crowdfunding platform. They've done this previously with some of their power stations. It gives you a chance to save some money, and they get to ship out the power station a little bit later. They are estimating shipment around August 2025. Let's take a look at some of the bundled options. Now I specifically chose 4 different bundles, but there are many more available. So starting on the left-hand side, you have the single Apex 300. Now this is launching with this super early bird price of $11.99, so only 43 cents per watt hour. Now, if you want to go up to their car fast charging kit, which adds the D1 hub and the Charger 1, you can actually pick this up for $1,617 or around 58 cents per watt hour, which is pretty decent for those added accessories. Now, what about if you want the Apex 300 with an expansion battery? Well, they're pricing that at $19.99 or around 36 cents per watt hour. So that's one of the lowest prices that I've seen for a Bluetti power station. So very good there. And then finally, if you want to get the Apex 300, an expansion battery, and the SolarX 4K, they're pricing that out at $24.49. Now that's over 5,500 watt hours of capacity for only 44 cents per watt hour. Now, if you guys don't have experience with a crowdfunding platform, basically you are incentivized to purchase the power station early, and each of these bundles are a first come, first served basis, so the better deals will sell out earlier, and then you will have to pay a little bit more money as the platform moves forward. Finally, I got all that out of the way, and now it's to the fun part of the video where we actually test the power station. Now, the whole purpose of this video is to show you guys how this performs. I'm going to show you real world performance. And this is not a sales video. I'm not here to sell you this power station. My job is to show you how it performs, and then at the end of the video, after watching all the tests, you can make a decision if this one's right for you or not. So let's jump into testing the AC inverter first. First, I wanted to see if the power station could run the maximum advertised load for 15 minutes, which is 3,840 watts. During this test, my oscilloscope was showing a super clean and crisp sine wave output, and I measured 120 volts at 60 hertz. After 10 minutes of running the maximum load, the cooling fans were at full speed. I measured 54 decibels with my sound meter from 3 feet away. I then used my thermal camera to confirm the power station temperatures weren't getting too hot. I saw a peak of 123 degrees Fahrenheit near the exhaust fan ports, which is a little warmer than I typically see during this test, but not horrible. The Apex 300 was able to run the full rated load for 15 minutes without shutting down. What is the maximum wattage the inverter allows you to pull before it overloads? I turned up the load from our previous test till it got up to almost 5,600 watts and the inverter finally shut off. It's good to see the inverter does have a bit of wiggle room if you need to pull higher than 3,800 watts before it shuts down. Now in the next test on the Apex 300, I want to see how well the inverter handles surge loads. So there are two different settings on the inverter. We have 120 volts output and 240 volts output. So first we're going to test the 120 volt output, see how it works, and then we'll see if the 240 volt output performs the same. So for our first test, I have this 10 amp air compressor connected up to the inverter. I have my Klein clamp meter here set to inrush mode, so it will track the amperage that it takes to power up this air compressor. And because this is an inductive load, instead of pulling 10 amps that it's rated for, it'll actually pull more than that. Now it's a little bit hard to see that with the light, but I'm showing 23.75 amps. So next we're going to step it up to a 12 amp vacuum. So if I hold that just right, you can see 42.81 amps. No issues powering that up. Now for the largest single load, the 15 amp table saw. Wow guys, impressive. 53.23 amps, no issues whatsoever powering up that table saw. Now for the final test on the 120 volt output, both the vacuum and the table saw at the same time. So they pulled a total of 60.15 amps and the inverter powered up that load without an issue. Now I'm curious if we can get the same amount of power on the 240 volt output. So I've selected 240 volts. We have the 50 amp connector down to a 30 amp down to this splitter. So I'm connected into one of the 120 volt legs. So I want to start with the table saw first to see how many amps it pulls, and then if it can handle that, we'll jump it up to the larger load. So let's start with the table saw. Okay, so we got 30.25 amps, but the inverter did overload trying to power up the table saw. So you can see the inverter blinking here with the alarms. Now this makes sense because when we're running this in 120 volt mode, you get both inverters powered together to give you more amperage. When you're running in 240 volt mode, each inverter acts independently, powering a leg of that 240 volt output. So let's see if this can handle powering up a vacuum or even the 10 amp air compressor. So let's go ahead and try the vacuum on the 240 volt output. Okay, so it powered up the vacuum just fine. We got a total of 28.73 amps. You can see that's slightly under the previous test, and the inverter did not overload. Now these were pretty interesting tests. If you need to power up a larger 120 volt inductive load, you're going to need to set the power station to the 120 volt output so you can get both inverters working together to give you more amperage. Now, of course, the Apex 300 does have UPS functionality. There's actually two different UPS speeds. These two outlets right here have a 0 millisecond cutover time, and these two outlets right here have a 20 millisecond cutover time, and we'll be testing each set of ports. Now, I've just started a stress test on the PC to simulate a load. Both the monitor, computer, and my studio lights are connected to this outlet here, and my oscilloscope is connected to this outlet to measure the cutover. First UPS test in 3, 2, 1, record. Now the results of this test are a little different than other UPS modes I've tested. For example, you can see the power cuts out instantly here and then resumes. However, instead of just going into a regular sine wave from that point on, it has this brief flat line and then the power kicks in. So between these two cursors, it's 12.2 milliseconds. Now I want to do a second UPS test just to see if we get any different behavior on those ports. So 3, 2, 1, record. So we got very similar behavior on the second test. So just this brief flat area after the power kicked in, and it was 9.3 milliseconds this time. Now the computer is still running after both of those tests. Now I'm going to shut everything off and swap over to the other ports. So I've restarted the PC and now it's powered off of these two ports along with my oscilloscope connected in. Let's do some testing. So we're going to find out if this side is slower or faster than the other side. So first UPS test, 3, 2, 1, record. So pretty similar results. Between these 2 points is 10.5 milliseconds. We get the cutout here and then some sort of transition and then a full resume in power right here. So one last UPS test, 3, 2, 1, record. Now here's the recording of that last test. Now it's just a little bit shorter, so we're getting 9.8 milliseconds, but a very similar pattern here. Now after both of those UPS tests, the computer is still powered up and running the stress test. And when we compare the results on each side, they are pretty similar. Remember, this was supposed to be a 0 millisecond cutover and this was supposed to be 20, but we actually got about 10 milliseconds on both sides. Now that's definitely fast enough to keep a computer running if you have a power outage. I also wanted to demonstrate how long the Apex 300 could run during an extended power outage. I connected the power station with one B300K expansion battery up to my transfer switch with all 10 circuits enabled. Up on the screen, you'll see a breakdown of what's powered by that transfer switch. And during this test, I saw an average of 300 all the way up to 800 watts being used, with the occasional jump in higher wattage as larger appliances were turned on. The power station ran for almost 16 hours before I decided to end the test because it was at 2% state of charge. In my next test on the AC inverter, I want to see if these outlets on the front and the outlets on the side have a floating ground or a bonded ground. So with the AC inverter enabled and the outlet tester plugged into these outlets, I've tested and each of them have a floating or open ground. Now we also get the same result connecting to the 120 volt 30 amp RV outlet on the side of the power station. Now connecting up to the 50 amp outlet, I'm also getting an open or floating ground. Now what happens when you connect in the AC charging cable? Well, it picks up ground from the charging source. You can see that all these outlets here on the front are now grounded. Now we're getting the same results on the 30 amp outlet and also on the 50 amp outlet. Now, does the inverter produce any interference? I measured about 1050 millivolts of EMI using my dirty electricity meter, indicating the inverter has a very low level of electromagnetic interference. I also connected my guitar amp into the inverter and the EMI wasn't audible and I didn't hear any noise. How much usable capacity should you expect when running loads off the inverter? I discharged the power station with the resistive load until the battery died, and measured 2,480 watt hours of usable capacity. This result is 89.7% of the advertised capacity, which is an impressive result. I also completed an additional capacity test with the B300K battery attached. When the power station shut off, I measured exactly 4,700 watt hours, or about 85% of the rated capacity, so still an excellent result. Finally, how much power is used as the AC inverter sits idle for a long period of time? Leaving the inverter enabled for 12 hours, set to 120 volts output, the state of charge had dropped down to 93%, meaning the inverter had only used 7% of the battery, or about 0.58% per hour. I also got the same result when testing on 240 volts output. The Apex 300 inverters are super efficient. So after all the AC inverter tests, the thing that stuck out to me the most about the Apex 300 is the idle power consumption. It is much improved over previous Bluetti power stations. For example, after leaving the inverter enabled for 12 hours, it only used 7%, or about 0.58% per hour, when typically Bluetti power stations use around 1.5 to 2% per hour. So very efficient idle power consumption on this power station. Also, the fact that when we did a discharge test to get the usable capacity, we got 89%. So that's a very good result there. Now, I do have a couple complaints after all that testing. One thing was the fan noise is just right on the border. For example, 55 decibels and below is acceptable, and we got 54. Now it does have variable fans, so when you are running a small load, the fans aren't very loud, but as you push full power output, the fans get pretty loud, and that's just because they use a smaller diameter fan that spins faster. So I'm guessing they probably wouldn't be able to change that, but it'd be nice to see just a lower fan noise on a future model. Now the last thing is the advertised cutover for the UPS. It's advertised to be a 0 millisecond UPS on this side of the inverter, but as I was testing, I actually got 10 milliseconds on both sides. So maybe it needs a firmware update because this is a pre-production model. It maybe needs to be ironed out a little bit more. 10 milliseconds is definitely good, but if they advertise it to be 0 milliseconds, I'd love to actually see that. So moving on to the next section of the video, let's test the DC output on the Apex 300. Now this is actually the first Bluetti device that I've tested that does not have USB ports or DC output on the unit itself. If you want that, you'll have to purchase the additional accessory called the D1 hub. It plugs into the battery expansion port and gives you USB output and DC output options, including a 50 amp output on the top, which is a ton of power. Now you actually have two voltage settings for the D1 hub. You have 12 volts, which will give you 13.5 volts output. And then if you go into the Bluetti app, you can adjust it to 24 volts output. You'll have to put in a password for Pro mode that is all 8s, and then you can get 24 volts output. Now once you get it set to 24 volts output, the regulated voltage jumps up to 27.1 volts. Now just be aware, I'll only be testing the 12 volt output, but that 24 volt option is available if you need it. Now let's start out with some basic testing. I have my load tester plugged into one of the 12 volt sockets. These are rated for 10 amps, so my load tester is set to 10 amps. It's right around 135 watts. Let's see if we can go up to 11 amps. So it is allowing 11 amps or 148 watts. Let's see if it'll do 12. Okay, it is allowing 12 amps or 162 watts. That's a first for Bluetti to allow that much power through a 12 volt cigarette port. Oh, and it did shut off. So it'll allow that power for a brief period of time and then it shuts off. Next, I've connected to the 5521 barrel port. It says it's rated for the same power. So I've set up a 10 amp load with my load tester. It's also pulling 135 watts. Let's go up to 11 amps. Okay, so we are also pulling the same power, 148 watts. Let's try 11.5 amps this time, just to see if we can run 11.5 amps continuously. So we are pulling 155 watts. Let's just let this go for a couple seconds just to see if it will shut off. This is actually an improvement over previous Bluetti products. Usually they cut out around 135 watts, so we are getting more power here. Let's go up to 12 amps now and see if it shuts off. Okay, last time it just, after a few seconds, it shut off. So this should also shut off. There it goes. So it overloads when you get up to 12 amps. Now what about pulling power from both 12 volt sockets at the same time? Now if you'll notice, these two ports are connected together, and then these two ports are connected together. Each one's good for 10 amps. So let's see if we can pull 10 amps from each one. So I'll set my load tester to 20 amps. Turn that on. Okay, so on the screen here, you'll see 269 watts output. It is running that without a problem. Let's step it up to 22 amps, just so we're pulling 11 amps from each side. Okay, we're pretty close to 300 watts on the screen. That's a good amount of power. So next, let's step it up to 24 amps. Let's see if this overloads it. I'd say this is kind of the upper limit for these 12 volt ports because we could not pull 12 amps through each one independently, so I'm guessing it's going to shut off. Yeah, so 323 watts, and then it shut off from being overloaded. So it's nice that it allows just a little boost of power there before it shuts off. Now it's great to see that the D1 has both 12 volt sockets and 5521 connections, but the main thing you guys want to see is the Anderson SB50 connection. This is good for up to 50 amps, so let's see how much it can handle. So let's set up 50 amps on my load tester and turn it on. Okay, there we go. 683 watts. Now I am hearing the fan of the D1 turn on. Now, it's not too loud. I wouldn't say that's annoying or anything, but almost 700 watts through that 50 amp port. So this has been going for about 3 minutes so far. Let's try 51 amps just to see if it will accept a little bit more power. Slightly under 700 watts, 698. Let's go to 52 amps just to see what happens. Now it does say the upper limit is 700 watts for the D1, and we are pulling, okay, right after we went over 700 watts, it did shut off the DC output. So looks like you can pull up to 700 watts before it actually shuts down. Now lastly, I want to test the USB ports. You have two USB-A ports here, and then you have two USB-C 100 watt power delivery ports here. Now connecting to the first 100 watt port, we are getting power delivery 3.0 at 100 watts, which is around 20 volts and 5 amps. Testing out the second 100 watt port, we are getting the same exact results. Now what about the USB-A ports? They are rated for 15 watts total. And connecting up my USB tester, we're seeing dedicated charging protocol at 1.5 amps, which is a little less than 5 volts and 2 amps. So we're getting about 10 watts from that first port. And connecting into the second port here, we are getting the same results, right around 10 watts. Now in my last test, I want to make sure that you can use the USB ports and the DC output on the D1 at the same time. So I'm charging the Anker C300 and this power bank, both with 100 watts input. I am charging my cell phone with the USB-A ports, and I have 39 amps going out of the D1 hub, and you can see that we are almost pulling 700 watts. So as long as the total output from the USB ports and the DC output don't go over 700 watts, you should be able to use both at the same time. But let's go ahead and turn this up to, let's say 43 amps, and that's going to go over 700 watts, and it will shut off the D1 hub. So just don't go over 700 watts total. Now, how much usable capacity can we expect as we're using the DC hub? Using my electronic load to discharge the power station, I measured a total of 2,654 watt hours as it turned off. These results were an astonishing 96% of the advertised capacity. That's awesome. Now, I also wanted to test how much idle background power the DC hub uses as it's connected and turned on. I started with the power station fully charged, and checking in 12 hours later, it was at 95% state of charge. So the DC hub uses very little idle power usage when enabled. Now I'm guessing one of the biggest complaints about this unit is going to be the fact that it doesn't have DC output built in or USB ports, and you have to purchase an additional accessory. Now remember, if you purchase it during the crowdfunding campaign, you can get this bundled for a cheaper price. And I will say that this does perform as advertised. It puts out a massive amount of power. It's the first power station I've tested with the 50 amp output, so that's excellent. It has a good amount of USB ports, and I'm hoping that this will be compatible with power stations that have this same connector. So a lot of Bluetti's power stations use this style of expansion battery connector. So will we see this compatible with other models? That would be really cool moving forward. So in the next section of the video, we'll be doing charging demos on the Apex 300. First, we're going to start with the Apex 300 on its own. We're going to do AC input, DC input, and solar tests. And then after that, we'll plug in the high-powered external solar charge controller called the SolarX 4K to see how fast we can get it to charge. Now, two different charging cables come with the power station. First, we have this AC charging cable. I love that they've gone away from a proprietary setup. This is just a basic standard AC charging cable. And then the next cable is for car charging. This is for 12 or 24 volt car charging. It plugs into a 12 volt socket in your vehicle. Now, as for the charging ports on the power station, if you look on the left-hand side, you have your AC input. This is the standard 120 volt, 15 amp input. And then you have a special input over here. This is rated for 120 volts and 240 volts up to 50 amps. Bluetti has two custom cables, one for 30 amps and one for 50 amps. Unfortunately, they did not send those out for testing, so I can't test this out, but this would allow for extremely fast charging. Now, moving on to the right-hand side of the power station, you have your DC inputs. Now, under this flap, you have two separate charge controllers. Each one has its own XT60 port. Now, these are rated for 12 all the way up to 60 volts, which is a little bit controversial compared to large Bluetti power stations of the past. Now, each one of these can have up to 20 amps input or 1200 watts. So a combined 2400 watts from these two charge controllers, and they do operate independently. Now, Bluetti has advised that this is designed for portable solar panels. Now, if you are wanting to connect up a high voltage solar array to the Apex 300, you do have the SolarX 4K that connects into the battery expansion port. This allows up to 500 volts or about 4,000 watts charging inputs. So at least you do have an option for high PV input through the SolarX 4K. So let's jump into some actual testing. I've connected the AC charging cable, and I like that the Apex 300 has this adjustable charging switch on the front. Now, you actually have three different charging modes. You have silent, auto, and turbo charging mode. I have it set to silent mode right now, and you can see we are charging around 500 watts. I've set the charging speed to auto, and now we are charging at 1440 watts input. And finally, I flipped the switch down to turbo mode, and you can see we're actually charging at the same speed. And that's because to go any faster, you actually have to go in the Smart App and select Pro mode to charge faster from the wall. Now, if you want to change the charging speed in the Smart App, you have to have the switch set to auto. So I've done that. And then also in the Smart App, I've come in here and I've changed the max grid input to 15 amps, which required me to enable Pro mode, which I did. It's all 8s as the password. And I've set that. And what's interesting is it's not changed on the screen. So for some reason, we are not charging faster than 12 amps input. I was hoping to get the full 1800 watts, but this might be a little bug in the firmware. Now, I quickly wanted to test to see if we could get 240 volts output while charging with 120 volts input. This is something that Jackery and Anchor have struggled to do. But if you check this out, we are getting 235 volts output while charging with 120 volts input. So this does support full pass-through charging. Now, I've been going through a bunch of settings in the Smart App just to make sure I have everything set properly, and I do have it set to turbo mode within the Smart App, and then under the advanced settings, I do have it set to 15 amps here with Pro mode enabled. So kind of interesting why we're not getting the 1800 watts input. Next, what about DC input on the Apex 300? I've set up my 1200 watt adjustable power supply to simulate batteries and solar. So we are going to connect that into one of the XT60 ports to see how fast we can charge at different voltages. So for the first test, I have the voltage output set to 13.5 volts to simulate car charging or charging from a 12 volt battery. And you can see the power station is limiting the input to 8 amps because I do have this power supply set to 25 amps output. Now, if you look at the screen here, we are charging at 100 watts. This will take about 30 hours, maybe a little bit less, to charge the power station if it was completely empty. So 12 volt charging is really slow. Now I've raised up the voltage on the power supply up to 18 volts to simulate 12 volt solar panels connected together in parallel. And you can see at this voltage, we've jumped up to 20 amps input, actually a little bit over 20 amps. Now, this is because I have it set to PV mode in the settings. If you have it set to other, you'll still get 8 amps input on the power station until you get over 30 volts. So you do have a setting where you can set solar or other. Now, if you look at the screen here, we are charging around 360 watts input. And remember, there are 2 ports. So you could connect a bunch of 12 volt solar panels into the power station and charge a little over 600 watts. Now, what about charging from a 24-volt battery? If you connected a 24-volt battery into the charging port, you'd see a slight increase in power. We were getting 350 watts, and now we're getting almost 550 watts. Now, what if you had a few 400-watt residential panels you wanted to connect into the XT60 charging ports? I've raised the voltage up to 36 volts, which is typical for a 400-watt solar panel at peak power. And we are getting the full 20 amps input. So you could connect two 400-watt panels in parallel to each of those charging ports, and you'd see around 740 watts on each port, or a little over 1,400 watts total. Now, what about connecting a 48-volt battery to one of the XT60 ports? I've set the voltage output to 54 volts, and we are getting the full 20 amps input, or around 1,120 watts. Now, each of these ports is limited to 1,200 watts, so this is essentially the peak input that you're going to see charging from a 48-volt battery. Now, in my final test using my adjustable power supply, I want to show you guys a realistic number you should expect from solar panels on these XT60 ports. Because of the 60-volt cutoff, you're going to have to keep your solar panels under that. So typically that's 12-volt solar panels in a 2S configuration, 2 panels in series, or you can have larger format solar panels in parallel. And the optimistic voltage I've set here is 42 volts. Typically, you're going to see under this. So 42 volts, a little over 20 amps. You're going to see around 860 watts input on each one of those ports, or a little over 1,600 watts total. So don't expect the full 2,400 watts input. You're going to see under that, so somewhere around this number. But I'll show you guys when I test with solar panels here in a bit. You're going to see something near this number. Now, what about dual charging on the Apex 300? Can you have AC input and DC input connected at the same time for faster charging? Now, if we zoom in on the screen, you can see the answer is yes. We are getting 866 watts from DC input, and we are getting 1,440 watts from AC input. So yes, this does support dual charging. Now, in the user manual, Bluetti also provides a breakdown of what you should expect with AC input, solar input, and the combined AC plus solar. Now, you can see a difference on each charging mode, for example, standard mode, turbo mode, or silent mode. And this is what you should expect if you are using the Apex 300 as a standalone without any expansion batteries connected. So I want to do a little bit more in-depth testing with pass-through charging. I have the output set to 240 volts, and I'm charging with 120 volts. Now, I have two heaters connected up to the 240 volt output. One 200 watt heater is connected to one leg, another 200 watt heater is connected to the other leg. Now, as for charging input, I have my DC power supply providing about almost 400 watts input there. And I have AC charging connected. You can see a balance between pass-through charging, so AC input and AC output. So everything appears to be working properly with pass-through charging, but I'm curious what happens if you flip this selector switch from 240 to 120 while you're running loads and charging. My guess is it's going to shut everything off and restart. So let's just try this out. Okay, so right away you'll see that the AC inverter does shut off. AC input stops and then starts charging, and the DC input just keeps going. Okay. Now you do have to turn the AC inverter back on manually. Now with this set to 120 volts, the heaters are still running. Now it's kind of hard to see in this lighting, but there is an LED light powered on for each one of these heaters, and they are putting out heat. So when you have this set to 120 volt output, you still get power to each one of these legs, but instead of split phase power, it's actually paralleled single phase power. Now, before we jump into the actual solar testing on the Apex 300, I want to test one other thing. So I have a bunch of 48 volt batteries here and connections up to that using these breakers. So I have two of these breakers with two wires coming off. I just want to see if the Apex 300 supports dual charging with the same source on those XT60 ports. So I've connected the 48 volt battery up to one of the XT60 ports. We're charging at almost 1100 watts. Let's connect up the second one and see if we can double the power. So I've connected in the second connection coming from the same 48 volt battery. And unfortunately, we are not charging at double the speed. We're still charging right around 1100 watts. So the Apex 300 does not support charging from the same source on both those XT60 ports. Now, what if you charge from two separate 48 volt batteries? Well, one charging cable is connected up to this one. The other charging cable is connected up to the rest of the 48 volt batteries. And if we look at the screen here, we are actually charging at 2160 watts. So yes, you can dual charge. They just have to be from separate batteries. So next I want to test the solar charging input on the Apex 300. Now you have two options. You have the low PV input, which is designed for portable solar panels because it has a 60 volt cutoff. So I have these portable panels that we'll be testing with for that input. And then we have the high PV input, which comes from the SolarX 4K, which we'll be testing with these larger format solar panels, which are wired in series. So let's test with these portable panels first. Now I've set up 4 of these panels. These are pretty large and expensive, so I think this is a realistic test. I don't see anybody going much bigger than this for a portable setup. So in the front here, I have 2 Renogy 400 watt panels. They are wired together in parallel. And then in the back, I have 2 450 watt Zoop W panels. They're also wired together in parallel. Now connecting those solar panels in is really easy. You have 2 XT60 ports, and as long as your solar panels end in XT60 or you have an XT60 adapter, you can plug them in and start charging the power station. So with all of those solar panels connected in, we're actually seeing a good bit of power, 1462 watts charging input. Now I'll say that this is probably the upper limit to portable solar panels just because we have this 60 volt limit, and also the amperage is limited to 20 amps. For example, if we wanted to add more solar panels to this setup here, we wouldn't see any power gain. For example, the Renogy panels are already connected in parallel for 20 amps. If we added an additional panel, we would be getting 30 amps, and the power station is limited to 20 amps. And we can't add any other solar panels in series because we go over 60 volts. So that's why I'm saying this is kind of the theoretical limit of the portable solar panel input. Unless you had solar panels that put out a little bit higher voltage than these, you'd probably see a little bit more power input. Now I'm excited for the next test where we can connect a bunch of solar panels into the SolarX 4K external charge controller. Now for that test, I've taken 10 of these 400 watt solar panels and I've wired them together in series for a total array of 4,000 watts. So I'm here in my basement. I have these solar wires that come in through this conduit. They go into these DC breakers. These are rated for 1,000 volts. And then I have that going into the SolarX 4K. Now the SolarX 4K is plugged into the B300K expansion battery port. It's really easy to connect everything up. And we also have a charging indicator light on the screen. Let's see how much power we're getting. Now if we look at the screen here, we are charging at 2820 watts input. So quite a bit of input through the SolarX 4K. Now some of you may be wondering, well, Jason, you have 4,000 watts of solar panels connected up. Why are you only getting 2,800 watts input? Well, actually, each one of these arrays has different brands of solar panels. So they are mismatched solar panels. They're also facing different directions, and I actually have temporary wiring for series connections between each one. So it's not ideal, but it just shows you the potential of the SolarX 4K. If these were all the same brand and all installed properly and facing the right direction, you'd see a bit more power. Now I also wanted to test to see if you could have the low PV input connected at the same time as the SolarX 4K. So I've connected the low PV input into my 48 volt battery bank here. So let's see how much charging input we're getting. So you can definitely have the low PV connected at the same time as the SolarX 4K. We are getting almost 4,000 watts charging input with both of those connected. So this can charge super quick with solar panels. Now just FYI, I let this go for a few minutes just to see what would happen, and as the power station hit 95% state of charge, it did back off on the charging input. Now this is typical for most power stations. As they get near 100%, they will start to slow down the charging input. So above 95% state of charge, I'd expect 1,200 watts input or less. I also tested having solar panels connected overnight on the Apex 300 low PV input. In the morning, once the sun started coming up, the power station started charging. I didn't notice any issues or hear any low voltage alarms during this test, so it's okay to have solar panels connected all the time. I also tested having the power station completely turned off and then connecting solar input. The power station turned on and started charging, so solar panels do wake up the power station if it's died or if it's been turned off. Wow, that was a lot of testing on the Apex 300, and hopefully you guys have a better understanding of how this performs. Now, I will say it's impossible for me to do every single test. I have limited resources. I don't have all the accessories nor the charging cables, so I just do the best I can with what I'm provided. Now, just be aware, if you guys have any other questions about this power station, you can leave a comment down below and I'll do my best to answer that. Now, I briefly want to talk about some of the specifications. I will say the user manual is loaded with a ton of information, so definitely read the user manual. They state that this comes with a 5-year warranty, which is pretty standard for products these days, so 5-year warranty is great. Also, the weight of this power station is 83 pounds, or about 38 kilograms. I would recommend lifting this with 2 people. There are handles on the power station to carry it around, and it's just better if you have 2 people. Now, I've had to carry this around by myself. It is possible, but you have to be careful when you lift. You want to make sure you're lifting with your knees and not with your back. Now, I briefly want to go through some of the new things that I've noticed in the Bluetti Smart App. It's very similar to previous power stations. For example, you have your state of charge, you have the power inputs listed at the top, you have your outputs listed at the bottom. For example, we have the AC inverter turned on right now. Now, below that, you have the ability to turn the Apex 300 off remotely with the power switch. Just remember, if you turn it off, you will have to be in person to turn it back on. You can see the components that you've connected up. So the SolarX 4K, I've used that, so that's showing up there. And also below that, you have a rocker switch for turning on and off the AC inverter. It's enabled right now. Below that, you can see the energy statistic. Now, this is really cool. It breaks down the power usage and consumption and charging for each day. So you can see we've had PV input here, 0.6 kilowatt hours input, and then also the AC inverter output, 2.9 kilowatt hours. So you can see input and output here, and you can break that down for each month. If you go to the top, you can see a breakdown just like a graph, so it's a little bit easier to read, and you can kind of track what happens with solar throughout the day. Now let's go through some of the advanced settings. There are just a few settings I want to talk about. The thing I noticed here is you can set the default connection mode to Bluetooth, but you also can put a Bluetooth connection password. So if you don't want someone accessing this while you're out and about, camping or something like that, you can put a password on here so they can't change any settings. There is one thing under working mode. I noticed that there is a time of use setting. So if you want to use this where electricity rates are expensive, you can run the inverter, and then where electricity rates are cheap, you can charge from grid input. So you can kind of use this to save power via time of use. So that's good there. And then I've also noticed under advanced settings, I just want to briefly talk about changing the grid input current. So we'll select that at the top. Now you do have to have Pro Mode enabled. Just be aware, to enable Pro Mode, you have to do all 8s as the password, and then you have the ability to adjust the current. Now this is going to be limited to the charging cable you're using for grid input. So the stock charging cable, even if you set this to 50 amps, it's still going to limit around 12 amps. So you can't damage the power station or burn up the cable. It knows what cable you're using, but it's good to be able to adjust this between 10 and 50 amps. So if you're using the 50 amp cable, you can go up to 50 amps. If you're using the 30 amp charging cable, you can go up to 30 amps, or you can go definitely under that if you want to charge slower. Now, if we back out of that, the last thing that I want to show you guys is grid self-adaption. Now, you want to enable this if you have really dirty power, or if you're charging from a gas generator that doesn't have the best power output. For example, you can set under voltage setting, over voltage settings, and you can also adjust frequency settings. So if you have kind of a generator that has dirty power, it allows it to still charge even though that power isn't perfect. And that's something that you don't see on other power stations. Now let's come to the point of the video where we're going to put this through my power station grading system. There are 20 different requirements. Each one's worth a half point, so we can get a total score of 10 points. So let's see how the Apex 300 scored. So take a look at this, 10 out of 10 points, or an A+ grade. It's pretty rare for a power station to get a perfect score, but the Apex 300 did that. And that's with me including the D1 hub, so you can get the USB ports and the DC output. So you will have to calculate in that slight extra cost. Now that pretty much wraps up the video today. I've completed all the testing, and I'm really interested to know what you guys think about the brand new Bluetti Apex 300. Now I'll say these accessories are pretty exciting. Can you imagine connecting the D1 hub up to the AC200L, or the SolarX 4K up to the AC300 or AC500? Well, they have the same battery expansion ports, so I have my fingers crossed that these will also be compatible with other Bluetti power stations. So make sure you guys let them know in the comment section that you want to see that as well. Now, if you guys are interested in picking up the Apex 300 during the crowdfunding campaign, I will include the link to it down in the video description. Remember, it's first come, first serve, and the earlier you buy the power station, the cheaper the price, because they have certain tiers that sell out. And you have about 2 to 3 weeks before that campaign is finished. And as always, a huge thanks for supporting the channel and watching these videos. A special thanks to Bluetti for sending these products out for testing so you guys can see how they perform. And before you leave, please smash the thumbs up button. I'll also recommend a couple of the videos that you might be interested in. We'll see you guys in the next one.